We continued using Jira for our project management, and thanks to this, we were able to efficiently see how our project progresses and update our time plan when necessary.
To make sure that the system would work not just in theory, but also in practice, we investigate some of the components ourselves in the condition we would be using them in. This helped us quite a bit in assembling the device, since when we tested the large pump, we realized that at 100% duty cycle, the pump would only pump around 0.6 liters per minute, which is remarkably lower than what the component datasheet advertised as 2 to 3 liters a minute. We also found out that if the duty cycle went below a certain percentage, the pump would not work at all.
After making console simulations modeling insulated and uninsulated energy transfer showing an effectiveness of 228%, we took temperature measurements. Observing 174% efficiency in our found result, this matches our simulations fairly well. Reducing the amount of components only increased energy efficiency by 3%. However, there was a great decrease in the cost of required components, increasing material efficiency and production requirements. There are many aspects of the United Nations 17 Sustainable Development Goals present in our system. These are mostly in the form of 7, 9, 12, 13 and 14, which primarily focus on material and energy. As well as the 17 United Nations Sustainable Development Goals, the 7 R's of waste management were also important in our design choices involving sustainable materials.
We validated our PID control with the finalized setup, and with some fine-tuning we achieved a pretty fast decrease to the desired value within the limits of our cooler and a fairly small overshoot. We've also finished implementing our web server, and our system now supports manual control of the cooler and the pump. It has real-time data, a historical overview, and a forecasting tool that uses regression to predict future trends. As an extra feature, we implemented email notifications for when our OD concentration goes below a set threshold. We first implemented SMS notifications, but because of the price for sent SMS, we settled just for email notifications. We then calibrated our OD sensor using manual measurements for 8 different concentrations and then used linear regression. We designed our system by first creating a mathematical model for the algae concentration and muscle growth. Thanks to this, we are able to decide that we can only use a single pump and have a continuous loop of water through the system. This is because we found that the algae is not able to outgrow the mussels because it feeds on the mussel excrement, and the mussels can't produce too much excrement because they feed on the algae. We persistently store our data in a MongoDB database. This database is on an AWS server instance that we periodically back up. We allow for export of this data into CSV and Excel on our website. We also store a copy of the data in a CSV file locally on the ESP.